So now we're going to talk about confidence intervals. And I'm going to start with an example. So this is a study from Pew Research. They're a polling firm that does a lot of research about people and their behaviors and opinions and things like that. I think actually a lot of my examples from this slide deck are from Pew Research. So in 2019, Pew did this survey of 4,860 US adults, and they found that 30% of adults reported using a dating site or an app. So if I needed to write out in notation, I could say that p hat is equal to 0.30 because that was a sample, not the entire population. It's not all US adults, but it was a nationally representative survey. So then the question is, how accurate is that 30%? That was just one sample, and they might have gotten people who were less likely to do online dating or more likely to do online dating just by chance when they took that sample. And so we want to know, what are some other values we could have observed? Is it centered right around 30%, 29 to 31%, or is it way wider? Like it could have been 10% or it could have been 90%. So this is what is useful about an interval estimate, is it allows us to give a range of plausible values rather than just saying my best guess for the population parameter is 0.30. I could say I'm pretty sure it's between these two values. And the way that we calculate this interval is we have our statistic. So that might be our x bar, our p hat, things like that. And then we have plus or minus the margin of error. And the margin of error is something that characterizes the variability of the estimate. So if you go onto a site like Pew Research and you see a report that 30% of adults have used a dating site, they're also going to give you the margin of error for that estimate. So in this case, the margin of error is 2.1 percentage points. And so we could make an interval estimate. I could have my sample statistic, p hat, plus or minus the margin of error. And in this case, it's 0.3 plus or minus 0.021. And I get this interval. So it's between 0.279 and 0.321. So if I had to tell you what percent of US adults have used an online dating site, I'd say, well, it's probably between about 28% and about 32%. And that would allow me to feel more confident about what I was saying than just saying, it's about 30%. So here's another example, again from Pew Research. They say that 30% of Americans have used Instagram online or on their cell phone, and they give a margin of error for this estimate. So I'd like you to try to give an interval estimate of the proportion of Americans who have used Instagram, and we can talk about that in synchronous class. I'm bringing back this election polling data that I showed you last time. And one question is, why is the margin of error different between these different polls? So it says MOE, that stands for margin of error. And if I look at the CNBC poll, the margin of error is 2.3 percentage points, and the Quinnipiac poll is 2.5 percentage points. So what's different about these two polls? See if you can figure it out. So the thing that is different is the sample size. So in that CNBC poll, they surveyed 1,880 likely voters, versus in the Quinnipiac poll, they only surveyed 1,516. So a larger sample size allows you to get more accurate estimates. We were saying that last time. So my text looks like it's running off the screen a little bit, but I want to use this Quinnipiac poll and calculate an interval estimate. So I'm just going to draw a box around it so I can see what the numbers are. And it gives me the p hat that I'm interested in, which is 0.50. And it also gives me the margin of error, which is 0.025. So if I want to find an interval estimate for the proportion of likely Biden voters, I can do the p hat plus or minus the margin of error. And in this case, that would be 0.50 plus or minus 0.025, or 0.475 to 0.525. So that would be our interval estimate based on that one poll. So usually we don't know what the value of the population parameter is. We're able to say, here's our best guess, our p-hat, here's our interval using the margin of error, but we don't know if it actually is telling us something super accurate about our population parameter. But the 2020 presidential election already happened. So this is one of those rare cases where we actually know the population parameter, in this case, the population proportion, or P. And in the actual election, Biden received 51.4% of the votes. So then the question is, did our interval contain the true population parameter, in this case, the proportion? And if we go back and look, the top end of the interval was 0.525. So yes, we included the true population parameter in our interval. So that's pretty good. Our interval was able to capture the true parameter. So far, I've just given you the margin of error, but you are sometimes going to need to calculate it yourself. The question is, how do you determine it? And if you have the sampling distribution, you just look at the spread of the sampling distribution. You find the standard deviation, which has that special name, the standard error, and we can use that to help us determine the margin of error. Again, statisticians shouldn't name things. So these are three separate terms: standard deviation, standard error, and margin of error. These are easy to confuse, but distinct. So be careful about those.